We now start with the new chapter in maths, that is standard 9th, triangles. So we start with the first chapter of geometry in this year, that is triangles. Now we know very well that triangle is a three-sided closed figure. So when I talk about triangles, I know that it is a three-sided closed figure. So the triangle, if I see this as a triangle, then it's a three-sided closed figure which can be named as A, B and C. You can see that the triangle has got three different parts. One part is this part, 1, 2 and 3 are the three vertices. Then AB, BC, AC are the three sides, and this angle A, angle B and angle C are the three angles. So three sides, three angles and three vertices is what the triangle contains, apart from other things which are also there. We'll see it later on. Based on the sides and the angles, the triangles are classified as, first of all, in case of sides, we see that if all sides equal, then it is called as an equilateral triangle. That's an equilateral triangle. If two sides equal, then it is called as an isosceles triangle. It's an isosceles triangle. If all sides different, then it's called as a scalene triangle. So based on the sides, we have got three types of triangles: equilateral triangle, where all sides are equal; isosceles triangles, two sides equal; scalene triangle, none of the sides equal. Similarly, based on the angles, we have got three kinds of triangles based on the kind of angles. The first could be first one is acute angle triangle, means all acute, all angles acute. If one of the angle is 90 degrees, it will be right angled triangle, means one angle is 90 degrees, and if one angle is greater than 90 degrees, it's an obtuse angle triangle. That is, one angle greater than 90 degrees. So that was a general thing about the different kinds of triangles. Different triangles are equilateral triangle, isosceles triangle, scalene triangle, acute angle triangle, right angle triangle and obtuse angled triangle. Now we see some more parts about the triangles. The more parts will be this way, that so this was the types of triangles. Now if I take this triangle and then I am drawing a perpendicular from here to this point, or from here to this point, or from here to this point, then these one, that is A, M, B, N and C, O. Okay? These are, that is A, M, B, N and C, O are called as altitude, because here AM is perpendicular to BC, BN is perpendicular to AC and CO is perpendicular to AB. So what is the altitude? The perpendicular drawn from the opposite vertex to the side. The perpendicular drawn from the opposite vertex to the side is called as the altitude. So altitude is the one which is the perpendicular drawn to a side from the opposite vertex. And the point over here, it will always be seen that all these three altitudes are concurrent. What do you mean by concurrent? Concurrent. It's called as concurrent. Concurrent means passing through the same point. Okay, concurrent means passing through the same point. So I can take this point as, let's take it as Z. So Z is the particular concurrent point over here, and that point of concurrent is called as orthocenter. So Z is orthocenter. Okay, that's the orthocenter over here. The next would be that if I got a triangle here, and if I draw the line which is making it midpoint, so this is A, this is M. So in this case, AM is the line which is dividing BC into two equal parts. So I have over here that M is the midpoint of BC. So AM is called as a median. So AM is median. Similarly, this could be like this. AN, so BN is median, and also CO is median over here because this is equals to this. The three medians again are concurrent at point Z, and Z point is called as the centroid. Okay, Z is the centroid. This is Z, which is centroid. Concurrent point of the three median is the centroid. So this way you see that the centroid is the one which is divides every median in the ratio 2:1. So here it is going to be 2:1. This is 2:1. This is 2:1. It's a property. You don't require it much, but yes, you can know it that it will be the centroid is going to be the point which is going to divide the median in the ratio 2:1. So that's about the median altitude. Now the next one over here is if I draw a circle to this such that the circle is such that it is passing through the three vertices, then such a circle is called as circumcircle. The circle drawn to a triangle such that it is going to be the passing through the three vertices is called as circumcircle. The center of that will be nothing but the orthocenter is the center over here. So this one over here is also the circumcenter. And this over here is the circumradius. Radius. This here to here is the circumradius. Okay. So that is the circumcenter. This is the circumcenter, the radius, and the circumcircle. Now, in case I draw a triangle and draw the angle bisectors, so iska angle bisector banaya. I make angle bisector of this. I make angle bisector of this. So this particular point, which is it is called as the incenter, and this is the radius, and there will be a circle which could be formed like this, that the circle touches the three sides. This circle over here is called as incircle. Okay, so one is incenter. The incenter is the concurrent points of the three angle bisectors of the three angles. The angle bisector of the three angles are the concurrent point of that particular point is nothing but the incenter. The radius, what is given over here, the perpendicular distance between this and this will be the radius, and that gives me the incenter. This is the incircle. So the circle which is touching the three sides from inside it is called as the in circle. So in center, in circle, circumcenter, circumcircle. Okay, these are the two kinds of circles which can be drawn to a triangle such that it could be either touching the vertices or touching the sides. Now we see some important properties about the triangle. So the first property what we are seeing is, if this is a triangle, the first thing is if this is angle A, B and C, A, B and C, it is seen that A plus B plus C is 180 degrees. That is, the first property is that sum of angles of a triangle is 180 degrees. We can easily prove this also. We can just extend this thing, draw a line parallel to this over here. When you take a parallel line, so this is the formation of a Z. So accordingly, if this is A, this will be A. This is the formation of corresponding angle. So if this is B, this will be B. So you know that A plus B plus C over here is nothing but 180 because of the straight line. So A plus B plus C is 180. So A plus B plus C is 180. Okay, very simple. So sum of angles of a triangle is 180 degrees. That's the first property. Second property is, you can see over here, this angle over here is the exterior angle of the triangle. So exterior angle is the sum of the interior two angles. A plus B is equals to A plus B over here. So its exterior angle C is equals to A plus B. So these are the two properties of the triangles. That first one is sum of the angles of the triangle is 180 degrees. And second property is that the exterior angle of a triangle is equals to sum of the other two interior angles. Exterior angle of the triangle is the sum of the other two interior angles. So there are the two properties of the triangles. Now we move on to the main part of the chapter on which this particular chapter is based, and that is congruency of triangles. So now what we have is called as congruency. Congruency of triangles. What do you mean by congruency? If two triangles are exactly identical, it is exactly the same. Like for example, I take these two pens, they are exactly the same. Color bhul jao. Size, shape, exactly the same. Because the size and shape are exactly same, then I call them as congruent figures. So here, if two triangles are exactly the same in shape or size, then I call them as congruent triangles. So if I have got a triangle over here, this is A, B, C, and another triangle over here which is P, Q, R. If I see that all the different parts of the triangle are equal, what are the different parts of the triangle? Of course, vertices ko lene ka zarurat nahi hai. So we got three sides and three angles. So if I have got over here that AB is equals to PQ, BC is equals to QR, AC is equals to PR, angle A is equals to angle P, angle B is equals to angle Q, angle C is equals to angle R. If this is going to happen, if this is true, then I can say that triangle ABC is congruent to triangle PQR. This is a sign of congruency. Congruency is like this. Equal to के ऊपर एक सोता हुआ S. So ABC is congruent to triangle PQR. I can say that the two triangles ABC and PQR are congruent if all the six parts of the triangle, that are the three sides and the three angles, are equal. If they are equal, then I can say that the two triangles are congruent. Now if I would have to check each and every and 6 conditions to be true, and only then if I am able to say that the triangles are congruent, then it becomes a very difficult task. So what they have done is that based on certain kind of conditions, it has been seen that if I have the 3 sides, or it means they have found out that if in a particular order 3 things are equal in a particular order, I mind it that it is only in a particular order. So like side, 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 angle, side. So that will be in that particular order. We'll learn that thing, what exactly I mean to say. That if it is only in that particular order, if you are seeing those sides between 2 triangles, if they are equal, then we need not prove the other 3 parts to be equal. It is automatically understood that both the triangles will be equal. Okay, so accordingly we have the 3 things as the first thing over here is SSS test, that is side, side, side test. This is called as a test, SSS test. So if I have a particular 2 triangles where I know if it is already given to me that this side is equal to this side, means I am given that this is equal to this is equal to this, and this is equal to this. That is AB is equal to PQ. You can see I am using different kinds of marking schemes to apply that this is equal to this, and this is equal to this, and this is equal to this. Okay, every time I am using different kind of symbols. So if it is given to me that the 3 sides are correspondingly equal, then I can say that triangle ABC is congruent to triangle PQR by SSS test. Okay, so if I know that the 3 sides are equal, then automatically the same triangle will be formed by any other method of drawing. This is actually speaking, if you go into a detail of this thing, it is based on the construction. If I give you to draw a triangle of side 3, 4 and 5, one side is 3 centimeters, another is 4 centimeters, another is 5 centimeters. You draw in any form कि पहले नीचे 5 draw करो, फिर 3 करो, फिर 4 करो, या नीचे 3 करो, फिर 4 करो, 5 करो, कैसे भी draw करो, अगर कट करके दोनों को एक के ऊपर कर रखोगे, it will be exactly the same. Means it is not possible to get a different kind of a figure if I am having all the 3 sides same. So based on that construction method, they have come up with this particular test of congruency. So the first test of congruency is nothing but SSS test of congruency. The next test is given as SAS test, which is side angle side test. So in this case, suppose I am not given that BC is equal to QR, but instead they have given me, so this is not given to me, but instead of that they have told me that this angle over here is equal to this angle over here. That means angle A is equal to angle P. Then also I can say that the 2 triangles are congruent, and then the test will be triangle PQABC congruent to PQR by SAS test, side angle side test. Again the same principle. If I tell you that you draw a triangle having one of the side as 4, one side as 5, and the angle between them is 60 degrees, you will not be able to draw any other shape of triangle unless and until if you use the same kind of measurements. The third side will automatically be same in both the cases, and the angles will also be the same, so the size and shape will always be the same. If we are here, very important, when I am saying the SAS test, I see that A comes in between the 2 S. That means the angle which is equal should always be the angle which is subtended by the 2 sides. See, this side and this side is making this angle. So it should be this angle which is equal to this angle. If this angle is equal to this angle, it is not SAS test. If I say that this is 60 and this is not 60 but this is 60, and I say whether it is congruent or not, but this is side, this is side, this is side, this is side, and this is angle, this is angle. No, this cannot be said to be as congruent. Or even if I am saying that this is equals to 60, then also it is not an SAS test because this is SSA. वो SAS नहीं है, यानी SAS में क्या होना चाहिए? Side, angle, and then side. It cannot be in another way. So it has to be in this particular fashion only, that one side, angle, and then another side. The two sides ka included angle should be the angle which is given to me as equal. If the two sides ka included angle is equal, only then I can say that the triangle is congruent. Got it? That is SAS test. Now, in the textbook, what they have done is that after this, they have given an exercise and then they have explained two more types of the, in fact, three more types of the test. So what I'll do is that I'll go for all the tests once at a time so that it's easier to understand. Otherwise, everything becomes, I think that will be a better way to understand this chapter. One sec. The next test what is there is given as, the third one is ASA test. An ASA test is the one in which you have two angles and the included side which is equal. That means if we are talking about this triangle itself, we are talking about these two triangles, then maybe we can consider it this way, that this is one triangle, this is another triangle. It is given that angle B is equal to angle Q and angle C is equal to angle R, and it is given that BC is equal to QR. So if it is this way, that angle B is equal to angle Q, BC, side BC is equal to QR, and angle C is equal to angle R. If this is the condition, then I will say that triangle ABC is congruent to triangle PQR by ASA test. So this is the method to be used if I am using this thing. Mind well, again, it has to be angle, side, angle. You cannot have this angle, then this side and this angle. Not possible. Okay? It has to be in a continuous form that nothing is missing out in between. Angle, side, angle. That means angles and the included side. In the same way as in side, angle, side. Side, angle, side was the angle which has been the included sides. Over here, the side between the two included angles. Okay, the two angles and the included, the side which is common between the two angles. Right? So that is angle, side, angle. It is also seen that even if I have something like this, that is, I am not given that this is equal, but instead, even if they give this is equal to this, or they give this is equal to this, I can still use this particular property by AAS or AAS. That is called as AAS test. That is angle, side. So it could be this way, that angle B equal to angle C or angle Q, angle C is equal to angle R, and AC is equal to PR. Then ABC will be congruent to PQR by AAS test. That is angle, side test. So these are the four kinds of tests which are going to be there for any normal triangle, any kind of a triangle. This is this per test: SSS, SAS, ASA and AAS. There is one special kind of a test which is there only in case of right angle triangles. So if there are two right angle triangles, so if this is one triangle and if this is another triangle over here, and it is given that this is 90 and this is 90, if I am given that this hypotenuse is equals to this hypotenuse and this side is equals to this side, see, you can see that it will be like ASS test. Is there any ASS over here? No, there is no ASS. Neither SSA. Okay, there is no there is no ASS or SSA. But in case of this right angle triangles, you have over here that angle. So this is ABC and this is PQR. We have angle B is equals to angle Q, BC is equals to QR, and AC is equals to PR. In that case, triangle ABC is congruent to triangle PQR, and the test over here is called as RHS test, that is right angle hypotenuse side test. So it is RHS test. Got it? So this is a special kind of a test only for right angle triangles. Only with a right angle triangle you can have this particular test, which is called as the RHS test possible. Otherwise, you cannot have something like SSA over here or AAS over here. It is not possible to have such a kind of a test for any other kind of triangles. Only in case of right angle triangles you have got this particular test, which is, that's why it is called as RHS test over here. So this is where the 5 different types of tests which are there for triangles: SSS, SAS, ASA, AAS, RHS. The whole thing can be remembered this way. It is 3 times S, then 3 times you write SA, SA, okay, and then you write AAS, RHS. So you are writing here 3 times S, 3 times SA, and then AAS, RHS. So this you can see divided into 3 parts. So it is going to be SSS, SAS, ASA, AAS, RHS. Okay. So this is the number of tests which are possible for the 2 triangles to be congruent. We will stop here and we will take the exercise and another explanation before the exercise in the next video.